Hi, everybody. My name is Sergey Kuksenko. I am from Java Performance Team Oracle, and today we will be talking about Asynchronous API and CompletableFuture. But because of I'm from Performance Team and I'm Performance Engineer and I'm responsible in general for Java, JDK, JVM performance, I won't talk a lot about CompletableFuture functionality. I will talk about CompletableFuture performance, performance tip, tricks which you could use to make your code which using CompletableFuture fast and well performant. Okay. A simple slide showing that you shouldn't rely on my words. I love that. Okay, I am working at Oracle last 8 years, and my experience with Java performance is quite big. What is Java util concurrent CompletableFuture? It's a new class which was introduced in Java 8, and at that time it wasn't used anywhere inside Java 8. I did a small survey about CompletableFuture just to understand how many people start using it. It looked like check the adoption of CompletableFuture on GitHub, how many repositories, just show it inside code. It's not a big number right now, but if you look into the trend, you realize that using CompletableFuture became bigger and bigger, and we will talk about how to make it useful for you. In Java 9, the situation became changed. We started to use CompletableFuture inside our internal API. As example, in Java 9 it was introduced Process API, which uses CompletableFuture, and it was introduced new HTTP client, and new HTTP client which works both with old HTTP 1.1 protocol and new HTTP 2 protocol. It's quite a large piece of code, heavily based on CompletableFuture, and most of tips and tricks which I will show you today are taken from that project. Before we will start talking about CompletableFuture, I just want to say a couple words about HTTP client. It's Java Enhancement Proposal 110. It was intend to make it in Java 9, but unfortunately it was a large discussion about how public API should look like, and that code doesn't become standardized in Java 9. It's a part of Java 9, but it's a part of so-called incubator model. Incubator model is a special feature also appeared in Java 9, where we could put some new experimental software, some libraries, some things. We could make that things available to public, collect feedback and change it, because of otherwise if we put new classes, new functionality directly into Java SE, we should froze that API forever. And incubator allows us to process feedback from the community, change it before standardization. Also, I have to say that in Java 10 this new HTTP client also located inside incubator, but it will be standardized in Java 11 and moved to the proper API. What an HTTP client is doing? It's a client. It works with the HTTP protocol. It sends request and receive response from HTTP server. And of that client there are two ways to send request. To perform blocking request, it means that we block on this method send. We send our request and we get result, and we should receive the response and process it somehow. And the second ability of that client is asynchronous request. We send request and continue execution. And instead of response, as a result of that function, we got a completable future of response. And with that completable future, we could do whatever we want. We could just block on that completable future and wait results, but it's not interesting for us. And the key feature of completable future, we could chain different actions a lot. It could be a large chain, it could be even net sum of actions which will execute it when we will finally receive our response and how to process that response. And another word about our client. Client have a lot of parameters. We could build it, specify versions, cookies, proxies, etc., etc. And because of its asynchronous client, it is able to work asynchronously with your code. We definitely should have ability to specify some executor service, some area where all asynchronous functionality will be executed. Because of without such ability, without providing control to user of our library, it would be not so good, because sometimes users should make restrictions for API and etc. It's really very nice feature to have this. Okay, what should be first step of performance if we have some library, some API, some new feature? I think, and I just say that first of all we should think not about performance of our programs, but we have to think about performance of our developers. When I did that survey on Twitter, I've got a lot of complaints that CompletableFuture and completion stage interface quite complex, a lot of methods, not trivial to understand, and etc. That is why I decided to spend a little bit of that presentation not talking about performance of CompletableFuture and performance of our programs, our libraries, but to talk about developers' performance. And it's like simple. What we have CompletableFuture, concrete class, which implements completion stage interface. Let's talk about completion stage initially. Completion stage has 38 methods, and if you look into them, realize that 36 methods have 3 forms: to do something async, to do something async without specifying executor, and to do something. And what does it mean? It means that something async means that all chain of actions which we construct at that point will be executed in the given executor. Again, the second kind of actions, making something async without specifying executor, is just shortcut for using fork join common pool executor. And otherwise we have chaining, which calls default execution. Quite interesting things. I will talk about that a little bit later in that presentation. Okay, 36 divided by 3, we got 12 methods to understand what are they doing. And 9 of them have 3 forms: apply, accept, and run. And apply is the most general form when we have results of previous future, and we have a function from that results of previous future to another results, and we transferring it from here. Accept, it's the similar situation, but our function doesn't produce results, not a function, and consumer. We just consume input and doesn't produce any results which should go later. And run, it's the most simple form. Run doesn't need any input and any output. It's just runnable, which will be executed when the future from which we depend are completed. Future is completed. Okay. Oh, this is these 9 function. 3 of them take input and produce results. It's one input, one result. Three of them, it's a binary OR operation. When our future is completed, when just only one of inputs is completed, and the third is a binary AND operation. It's the case when our future completed only when both inputs are completed. That's powerful enough basic set of operations which allow us to make actions, nets, chains, etc. arbitrary complexity. That's enough. Okay, we have three other methods: then compose, candle, when complete. Then compose. It's the most powerful methods of CompletableFuture. If we have function which takes input and produce not some arbitrary results, but produce result type of which is CompletableFuture itself. If you use then apply, you will get as result CompletableFuture from our results. It not a good situation in some cases. And then compose do flattening. For those who familiar with functional notation, is a simple flat map, and it's very powerful thing. I will show examples how to use it later. Handle, it yet another function, and in contrary with all previous functions which I described before, handle could process not only normal completion of future but also exceptional completion of future. Each completable future could be completable by two ways: normal completion and exceptional, some kind of exception which propagated also through all chains. When complete is like accept method when we take results, and when we take result of previous completable future and we don't want to produce any kind of results, but when complete again take both kind of inputs, normal completion and exceptional completion. Two other methods I think not so interesting, and let's talk a little bit later about CompletableFuture method itself. It has a lot of methods to complete future. Complete it explicitly, cancel, or make a timeout completion. I just have to say that complete on timeout methods appeared in Java 9. That functionality wasn't exist as Java 8 time. We have 4 ways to get a value from CompletableFuture. We could block at some point and wait until the result will be available. We could do it with timeout, or we could just check if there is a value or not. And of course we have sometimes useful methods which allow us to check status of our CompletableFuture. And also a bunch of static methods which allow us to create future, to create completed future, failed future, to start some execution asynchronously, which produce results for our future, and all other stuff. Okay, what should be done first? Blocking Asynchronous API. Let's consider those things. We want to make two functions which do the same, almost the same, but one function do something and produce results immediately after invocation, and another function, just like a synchronous function, doesn't produce result immediately. Instead of it returns a completable future which may be completed some later. Because in case of HTTP client, it's obvious way we could wait response from the server quite a long time. The question is, do we really need to implement both functions independently, or we just could express one function via another function? Yes, theoretically we could do that. If we have asynchronous API initially, do something synchronously, we could get our asynchronous future. We could get our completable future, our asynchronous results, and just do join and wait at that point. It's a simple way. We got our blocking API. The second way, if blocking API was before synchronous, could we just start execution of that blocking API somewhere in different threads in our executor and receive our completable future? Theoretically, yes. Let's try to dig a little bit deeper in that situation. Consider the first situation. What if blocking API is implemented using asynchronous API as a base? Will it work? Definitely yes. Let's check it, what will happen here. So our execution, our useful work is transferred to another thread, executor thread, and when it finished, we return to user threads when we perform blocking. So do we really need it such way? Let's check. It's a benchmark. Which performs some useful activity. I did some useful work on 100 nanoseconds, 100 microseconds, and 100 milliseconds. And here useful work is a blue, it's a 100%, and orange is a asynchronous overhead, which we received here in general. And here we could see that for small tiny task, asynchronous overhead is huge. For middle-sized task, asynchronous overhead is small. It depends how big 9% will be for your task. Is it large overhead or not? It depends on you. And overhead is almost negligible for large tasks. But it's a situation when only one thread, I mean user thread, is performing useful action. What will happen if you start increase amount of threads, working threads in our system? That measurement I did on my laptop, just to do it quick, fast, and show on server machines the picture will be worse, definitely. And my laptop has only 4 hardware threads, and here you could see that in situation when my hardware, my system is saturated, I don't have enough free resources, the overhead of asynchronous API could be visible because of, I think, 30%. It's quite a large number just to drop it off. And that is caused because of task transition from one thread to another. It costs always. It costs maybe small, it may be large, but if you want really high performance API, high performance system, you should avoid the situation if it is possible and if it doesn't create problems for you. Okay, let's consider the second way. When we have blocking API, what if we'll just execute our blocking API in our executor and we will receive response wrapped into CompletableFuture in that case? Will it work? Let's move from abstract API just particularly to HTTP client. How will it work? Again, my answer is sometimes. Of course, sometimes it will work, but I know situations when it doesn't work, and I want to explain such situation to you. So how simple HTTP request works? I have to say that on that slide, it's what you see on that slide is a very simplified picture, but it's enough for us. What word receive means in that case? It means that we have to wait header from server and wait body from server. Quite simple. So how it works? We do send. We are waiting. From other thread we should receive response and send notify signal. Okay. When we receive a response, process it and wake up our execution thread, it works. But I will warn you, don't do this that way as it's shown on that particular picture. Why? Because of what if all threads from our executor are blocked in a wait condition? We don't have a place to receive response and process it. And properly we need some auxiliary threads which doesn't control by end user. I'll call sometimes very important threads, and our API executed it and provides all required stuff. Particularly for this HTTP client, only the single auxiliary thread is required, and our goal guarantee that this very important thread will be never blocked. Because of it, that thread should receive response, should process everything incoming information quickly and distribute it to waiters which wait. Okay, it's look like everything is fine here, but it's only half of the picture. By default, our HTTP client is used cached thread pool. Honestly, it wasn't a very good choice for default executor, because of cached thread pool has some advantages and disadvantages. And the most biggest advantage of cached thread pool is also the most biggest disadvantage. I am in the situation that if all threads are busy, the new thread will be created. As advantage, it allows you to get your task executed immediately after submission, even if all existing threads are busy. But it means that a new thread will be created, and creation of a new thread could be expensive in some conditions. Just example, it was before tuning, it was the initial stage, and we realized that sending asynchronous HTTP request creates approximately 20 threads. Does it mean that if I want to make 100 simultaneous requests, I will create 2000 threads? No, it means that I will get out of memory error. Sometimes I just have no resources to make yet another thread for execution. And this is that case which I want to show you, that sometimes it won't work if we are unable to create a new thread. It's not working. Okay, how to deal with that situation? First of all, we should eliminate all waitings, because of if blocking API perform wait on condition or on monitor, it's okay, it's fine. We are waiting in user thread, and anyway, it's a blocking API. User thread expect results when our function completed. It means that if we are unable to produce results without waiting here, it's okay to wait. But what about asynchronous API? All actions are performed inside our execution service, inside our executor. And if we blocked here, we steal our thread from execution. We steal our thread from a pool of useful threads. We waste resources of that thread. If there is a way not to block, but return our threads back to executor in order to make something else, some other actions from our executor and produce useful results. Okay, what we have here? We have executor thread, which performs wait on condition, and we have our auxiliary very important thread, which woke up our threads, our condition to making that response received. First step, I have to say that CompletableFuture could be used as a single use condition, exactly as shown here. Again, of course, condition could be used several times. It's much more powerful thing, but particularly for that task, it's enough. We are using these notifications that the response received only once. We don't need the second response, etc. Okay, let's move to CompletableFuture here. It's only first step. It gives us nothing yet. The second step. Let's inline our method send into supply sync and split all actions on different stage. Okay, what we have here? We send request, then apply function, got something waiting signals that our response received, and just process that response. And here is a point of blocking again. But what if I will write such code? I replace and apply functions and compose. I just inject my CompletableFuture, which I'm using as a signal, into the chain, call then compose, and later I'm just processing response. If I invoke construct that chain when response received already completed, so it means I received my response, the whole chain will just continue execution and everything will be fine as expected. What if my CompletableFuture, I mean response received, is not completed yet? It means that the chain of execution will be constructed. It will be remembered internally inside CompletableFuture, but my thread, I mean that thread which perform completion of actions here, it won't be blocked. That thread will be returned to executor service, and that thread could do something useful for other tasks, for the whole system. And it's a key stuff here. So what I have here? I have future, I have then compose, and I have completion of that future somewhere later, and subsequent chain executed not exactly at the then compose point, at the point when I invoke then compose. That really saves a lot of resources, and that simple elimination of blocking inside Asynchronous API gives us on real performance examples of 40% of performance increase by 40%, and I think it's the most useful performance tip for CompletableFuture. And it's not only about performance. As I told before, blocking threads is not useful because we are wasting resources. That's quite important resource, and it could lead to errors. It could lead to out of memory errors, or even some other issues. It may help improve the whole stage. And so if you are making asynchronous API, we shouldn't block inside. We have internal threads. It could be executor threads, it could be some auxiliary threads, but we shouldn't block here. It's quite important, and CompletableFuture is the best way to avoid that using standard GTK features. Okay, let's move further, and I'd like just to ask you about the first question. If we have two threads, and from one thread we are constructing chain to our future, and from other threads we are just performing completion of that future, so where our action will be executed, from which thread? Some way it should be executed anyway, and the proper answer is here. It could be executed from both threads, and let's understand how it works, because of it quite important sometimes, and particularly for your performance you should know that answer. So where exactly computable future change or functions will be executed? I'm talking right now about default execution, when I don't specify explicit executor. I'm talking about default execution. There are two simple rules. If we are chaining actions to completed future, to already completed future, that action will be executed immediately at the point of constructions, and they will be executed in construction thread. The second rule: if we are completing some future and that future already has a set of actions, some chain of actions, that chain of action will be executed from completion thread. It looks like the situation is simple and rules are simple, but reality a little bit more complicated. There are races. What if my construction and completion perform simultaneously from different threads? What will happen here? And here I'd say that you shouldn't expect something straightforward. You should expect that your action could be executed everywhere. It could be executed from completion thread. It could be executed from construction thread. Even it could be executed from value getting thread, when we just get value, get it now, joining and blocking. A lot of situation could be here. And in order to prove it, I decided to show some examples. We have, OpenJDK, we have such tools which called Java Concurrency threads. It's some harness which allows to check different, particularly racy situations, and etc. Let's consider the first example. What we have here. What above this line, it's precondition. It's that executed long enough before last stage. This complete and then applied two different threads. That thread executed simultaneously. And in order to check real concurrency behavior, we have to do a lot of milliards, billions times, and these threads do it for us and tell us how frequently I've got one or other results. In this example, I have completion thread, I have construction thread, and I could see that my action could be performed from both threads. Of course, there is some imbalance between 1.5 billion and 200 million actions, but if I'll change timing of that action, I could get completely different numbers. Okay, the other situation. What if my chain is completed along much before completion, and I'm just doing completion from two threads? It's normal for CompletableFuture, and in case of such racy completion, only one of them will be successful, and another completion will be failed. And methods complete or CompletableFuture returns boolean, just to tell us if completion was successful or not. And I realized here that in case of such racy situation, my action could be executed not only from successful completion thread, but even failed completion thread could perform some of my actions, from my change attached to CompletableFuture. Third example, one thread is doing complete and another thread just joining, just blocking and waiting results. And again, it's a racy situation, and my action could be executed as well from completion thread and from join thread. And the last example, I have two actions, not a chain. I have two independent parallel actions attached to original CompletableFuture. And I have two threads, one completion, another join, and I we have a situation when both actions are executed from one thread. It could be completion thread or joining thread, but frequently I have a situation when my action is executed in different thread. It means that one action is executed from completion thread and another from joining thread, and it brings some chaos into understanding where my action will be executed. Not so good for us, but do we really need method like then apply? Maybe it makes sense to limit yourselves only with then apply, with an apply sync method, which has explicit executor. Let's talk about performance. Maybe it will be faster. Okay, let's check the performance. Again, I have useful work with 100 milliseconds, 100 microseconds, 100 milliseconds, and I have two benchmarks. One is benchmark, well, both of these actions executed in the same thread. It's a left line, it's a blue line on my charts, and the situation when each execution of task is transferred to explicitly specified executor, synchronous task. Okay, and again for one thread I could see large overheads for small tasks and small overhead in other cases, but again, if my system is saturated, anyway, overhead from explicitly specified synchronous execution could be visible because of I have to transfer task from another thread to another constantly, and that is why we have these two forms of method in CompletableFuture. Because of then apply async or do something async, it gives you predictability where that particular action will be executed. But default execution, when we forget about executor and just doing as it was shown as examples before, it gives for us performance, and it could be important. And again, why it better performance? Because of we are avoiding transition task from one thread to another. It costs. And I definitely want to say when predictability is important. Where performance is important, it's other question. But sometimes predictability is quite important. Our main very important threads for HTTP client is called selector manager. And his goal is reach data from socket and distribute decode frames to HTTP to receivers. So let's imagine what we have here. We have a future, our future, which should awake subsequent chain execution. We have action foo, our internal action foo chained to that future, but because of we return our completable future to users, user also could chain other actions here. And foo adds our foo function from our library, and bar is a function from user library, which is specified and attached to execution. What will happen if we are doing complete from our selector manager thread? It means that methods foo and bar will be executed from selector manager thread. Not will be, but they could be executed from selector manager thread. And as I told, selector manager thread is a very important thread. That thread should not block. It should process all receiving data very quickly and distribute it to receivers. And that may create problems because of even known for us function foo could take a long time, but the user specified function bar is completely unknown for us, and it's a way to failure to deny service of our HTTP client. It's a very bad situation because it means that we can't use complete from selector manager, because of if we will perform complete it means we could bring all long chain of CompletableFuture, uncontrollable for us chain, into our very important thread. It's dangerous. So what we have to do in Java 9, we could use new methods complete async. It means that method explicitly specify executor for subsequent execution of our chain. In Java 8, there are no such way to use complete async. It means that we should protect our chain on other side from the executor threads, again explicit moving to executor. That both solutions completely similar in terms of performance. Our very important thread is protected, but what we got? We are switching from one executor thread to another executor thread, and it costs for us. And for high performance, maybe it makes sense to avoid that situation. If we are sitting in a situation when we are already working inside executor thread, and we know that execution will be continued to executors inside the executor, maybe it doesn't make sense to specify that asynchronous explicitly, because of such specification will move only simple move from one executor thread to another executor thread. This is code how to avoid that, and how we did it. We just checking. So if CompletableFuture done, it means that if future is done, it means that all chain will be executed exactly from that thread immediately. We know that. And if CompletableFuture is done, in some cases it happens, we don't need protect our future by explicit move to executor. If CompletableFuture still incomplete, we should protect it in any case. And that simple trick gives us yet another 16% of asynchronous API performance. Okay. Again, transition task from another thread, from one thread to another, it's always complicated stuff. Okay, and another trick. What I realized, in some point we have the same code, similar code. We send header asynchronously, got CompletableFuture, then compose sending body and processing response. And it realized that in some cases, it's if just count by number cases, it's not a big amount of cases. It's only 3% of cases. But when we came to last line here, our CompletableFuture, I mean CompletableFuture which used for chaining, it's already completed. And because of it's already completed, it means that the rest of our chain is executed from user thread. But from other point of view, we don't want to execute something from user thread. We have an executor service, we have explicitly specified executor. We want to make all stuff only inside that executor. Okay, what we could do? We could use explicit specifying executor. And again, in that situation, user thread will be protected, but it will cause unnecessary switching task from one thread to another. And I suggest to use the following example. I make incomplete future. It's a start. After that, I construct my chain. Because of the initial future, the origin of that chain is not completed. It's by construction. None of this action will be performed from that point. I'm able to make the whole chain successfully and without any execution. And only when the whole chain which required for me is constructed, I'll just start the execution. And complete the initial future, and the whole chain start running inside specified here executor. I called it delay start, just not to mix construction and completion stuff. And that delay execution gives for us 10% of overall HTTP client asynchronous performance, because of we don't transfer task a lot of from one thread to another thread. Okay. The probably last example which I want to consider here, it's not really related to CompletableFuture, but because of anyway we are working with asynchronous, we have with executor service, thread pools and similar stuff. We should think about that. And as I told you, cached thread pool is default executor for HTTP client. Is that good enough? As I already told you before, it's not a good idea to use cached thread pool. I shouldn't think here, just checked and run through a lot of different executors in order to understand which executor will be better, and I realized that fixed thread pool with only 2 threads gives us yet another 32% of performance. It's 32% better than default executor cached thread pool which we use for that. Okay. Again, if you're working with Asynchronous API, don't forget only about completable futures. Just think about executors, because of anyway you have to specify it and work with that somehow. And before we'll start to before you start to ask question and answer, I have to say one thing. If we check all hints, conclusions which I wrote through the presentation before, usually they are related to threads. Yes, and the reality is the following. Yes, CompletableFuture is a very nice, powerful asynchronous abstraction which allow us to create fine and normal functionality which does not depends on threading, runables, and etc. Maybe it allows you really don't think about that. But if you have to provide a better performance, if you have to provide high performance, if you just even have to think a little bit about performance, you have to understand how all these threads and all that stuff works beneath CompletableFuture. And having that understanding, you will be able to create a really high performant API. I have a couple notes, I have appendix. Usually I don't tell about that on presentations. Just note its example. You could look into that later if you're interested in download slides. It's a simple example how to make recursive CompletableFuture chain using method then compose. It's really a nice feature. I mean, then compose method. I love it. Okay, thank you very much. I'm definitely finished and I'm ready to answer questions.